Hello, welcome again. It's Martins Mwalimu. I know nimekaa sana almost two weeks kama sijaposti kitu, but today I'm here tumalizie the topic magnetism. I remember tuliachia pali ya the methods of magnetizing and demagnetizing magnetic material. However, today tutamalizia the last part of which the parts include number one, tutaangalia the hard and soft magnetic materials. We'll look at the domain theory. We'll look at how we can store magnets, applications of magnets, and at least at that part tutakuwa tumefanya kakitu. So let me start with the soft and hard magnetic material. Now, when you are magnetizing a material, there are these two categories of materials. There is a material like iron. This material is a material that can be magnetized easily and very fast, and it attains a very strong magnetism or magnetic field. Very fast, attains a strong magnetic field, less time. Such kind of materials, they are called soft magnetic material, e.g. iron. The way they are fast to magnetize is the same way they are fast to demagnetize. So when it comes in demagnetizing, they are also very fast to demagnetize. So what are soft magnetic materials? These are materials which are easy to magnetize but also easy to demagnetize, e.g. iron. Then there is this other category of magnetic materials, that is e.g. steel. A steel is a material that when you are magnetizing, it is very hard for you to magnetize it, and at the same time it is very hard for you to demagnetize it once it is magnetized. Such kind of materials, they are called hard magnetic materials. Soft magnetic materials inatumika pali kama they are used as cores, CORE, kwa transformer, electric bell, etc. But now, and magnetic materials like steel, they are used to make permanent magnets. Are we together? Yes, the next thing is about the domain theory. Hapa itabindi ni kuonyeshe for a domain theory. Tutafika hapa in this diagram. Now we will talk of magnetic material and the magnets in terms of domain theory. Now, in domain theory, it states that every material, provided a magnetic material, it is made of sections. Unaona the way I've divided it into section. Each section now, a section like this is called a domain. A section is called domain. So it's made up of several sections. Those are called domains. But inside those sections, there are dipoles. These are just particles. We represent them with arrows. So these, we call them the dipoles. Now, the dipoles in a domain, for magnetic material, the dipoles in a domain, they are the ones that constitute or determine the magnetic property of a material. Now, if a material is magnetic material, then dipoles in a domain, in a single domain, they face the same direction, making that domain, that section, to have both north pole and south pole, because each dipole has north pole and south pole. So when they face the same direction, each dipole has north pole and has each domain has a north pole and a south pole. Now, but you see, for the next domain, they are facing also the same direction but different direction as compared to the initial domain. So therefore, the magnetic field cancels out because the dipoles in domain are not facing the same direction. These are magnetic materials. The dipoles in each domain, are not facing the same direction as the dipoles of the next domain. However, the dipoles in a single domain, they are facing the same direction. But now in a magnet, all the dipoles in all domain face the same direction. In a magnet, all the dipoles in all domain, they face the same direction, like that you can see. They face the same direction. For that reason, when they face the same direction, we say this is a magnetic it's a magnet, not a magnetic material. So what happens when you are magnetizing a magnetic material to become a magnet? You apply a magnetic field either by stroking, by electrical method, or any other method. So that magnetic field is what forces or what causes this dipole domain and the dipoles in domain, all of them to face the same direction. So when you apply an external magnetic field, these dipoles face the same direction in every domain. Zote zinaangalia the same direction. Once all of them face the same direction, this is a situation where the material is tend to be magnetized. And when all the dipoles have faced the same direction and no more dipole is left such that we cannot magnetize that magnetic material anymore, we say that that magnetic material is magnetically saturated. So that is all about the domain theory. Unless kama utapata question utaniulizia some other time ama hata kwa comment you may ask me there, I will answer. So that is all about the domain theory. Now can I go to the storing of magnet? Now when you leave a magnet for long time, ikiwa peke yake, it tends to demagnetize because remember it is interacting even with the magnetic field of the earth, and some more factors like it, vitu mingi zina cause it to undergo demagnetization. For that reason, a magnet should be stored, well stored, so that it cannot lose its magnetism. So how do we store magnet? This is how we store magnets. We place two magnets like this. This is a magnet and this is a magnet, but we place them in such a way that they have the opposite poles adjacent to each other. Kama hii ni north pole inakuwa south pole, kama hii ni north pole inakuwa south pole, that way. And then we use these things we call keepers. They are not a special thing, it's just metal, and preferably we prefer iron, a magnetic material. Iron, we prefer it because it's a soft magnetic material. It is easily to magnetize and easy to demagnetize. So when it is placed here in this magnet, it becomes magnetized. Iron obtains opposite pole by induction. If you can remember, hii ni south pole, ina obtain north pole. Hii ni north pole, hapa ni south pole. Hii ni north pole, hapa ni south pole. Hii ni north pole. So for that reason, they form a loop such that the magnetic field around this structure forms a loop, and this avoids or prevents the magnets from losing their magnetism. And this way we say that we have kept the magnets. Now, what are some of application of magnets? Magnets are applied in different areas. Several of them, hata kwa kitabu ni chache, they are several. One, they are used to make magnetic screw. Zile za kufungua simu, unafungua hivi, unainua nut, unaona hiyo ako ka screw kameshikwa. That's a magnet applied there. In loudspeakers, kifungua redio upate hiyo speaker inaongea, there is magnet there. MRI, those are used in medicine, zina scan body, magnets are used there. Hand disk ya computer and several areas. So with that I think we will end up tutamalizia hapo, and maybe next time we'll start on another topic. Thank you.